Alrighty, children, we're going to start Unit 4 here. We're going to start with some quadrilateral properties. There's quite a bit going on here, so we'll try and focus in on some different pieces as we go along. But we're just going to go ahead and take a look at each one. So this is the quadrilateral family tree. Quadrilaterals have 4 sides. Alright, now you'll see it kind of branches off from just being a quadrilateral to a few different main categories. So we've got the parallelogram, we've got our kite, we've got our trapezoid. Okay, so let's start with our parallelogram here. Parallelogram just means it has opposite sides parallel. The opposite sides are also congruent. The opposite angles are congruent. The consecutive angles are supplementary, meaning this guy and that guy are supplementary. And if you remember, that means they add up to 180. And like this angle and this angle are consecutive, so they're supplementary. This angle and this angle are consecutive, so they're supplementary, so on and so forth. Okay? Our diagonals of a parallelogram bisect each other, and that was a terrible job with the laser. I'm trying to see it. Diagonals bisect each other. Okay? And don't worry so much about this one down here. It's one that we can use to prove something's a parallelogram. But yeah, we won't worry about that too much. Alright, so that's a parallelogram. Now everything else stems off of that below. Alright, now the main ones we'll be concerned with will usually be like our opposite sides being parallel, because that tells us stuff about angles, and also the opposite sides being congruent. Those first two are the main ones, but we will use each and every one of those properties in the context of construction. Just the two first ones, those are the main ones for construction class. Alright, so let's take a look at these guys below here. Let's start with our rectangle. So rectangle is basically everything the exact same as a parallelogram. The only difference is that the diagonals are congruent and it has 4 right angles. Okay, so all of these properties still apply to a rectangle, but the diagonals are congruent and it has 4 right angles. Now, if you remember, if we're framing up something that's square, for example, framing up for concrete, like a rectangular patio or a shed or whatever, or a doorway, even if we're not a concrete doorway, but we're framing up a doorway, you want to check and make sure that it's quote unquote square, and you can do so by checking if our diagonals are congruent. We've done that before in the context of construction. This is the formal introduction of it in the math component. Okay, so because it has congruent diagonals, it's a rectangle. And what do we know about rectangles? We have 4 right angles. So once you've been able to prove that it's a rectangle from the congruent diagonals, you can then get this property from it as well, which is the 4 right angles. So the rectangle, in all honesty, is probably the most important quadrilateral in our class. We use it so frequently, so that is it. That is a biggie in the construction component. On the other side here, we've got a rhombus. All right, a rhombus is basically a parallelogram. The only difference is all congruent sides, and then you get some other wonderful stuff going on here for 3, 4, and 5. The diagonals perpendicularly bisect each other, meaning they are perpendicular to each other. They form right angles. And they also bisect each other, meaning they split each other in half. All right. The diagonals bisect the angles, so they split these angles into 2 congruent angles, bisecting again, splitting it in half. And the diagonals divide the rhombus into 4 congruent right triangles. That's just kind of a fun fact more than really anything else. Okay. Main thing is with a rhombus, all the sides are congruent. That's really the only difference from a parallelogram. All right. The square we often refer to as the love child of the rhombus and rectangle. Okay. It's got 4 congruent sides, much like a rhombus. It's got 4 right angles, like that rectangle over there. The diagonals are congruent, just like a rectangle. The diagonals split the angles in half. They bisect the angles, just like a rhombus. So you get basically the combination of those two when you get a square. All right. Let's pop on over to the kite, which is like the black sheep of the family. Okay. It's not a whole lot like any of the others. The only one thing that it relates to would be the perpendicular diagonals, much like a rhombus and a square. All right, but only one diagonal perpendicularly bisects the other. All right, one pair of opposite angles are congruent, and only pairs of sides like these two are congruent, and then these two are congruent. All right, so it's kind of a funky looking shape, but yeah, it's super duper cool. We'll mainly focus on a rectangle, and then also you'll see our isosceles trapezoid pop up here quite frequently. So let's take a look there. So trapezoid just means that opposite sides are parallel. That's it. One pair of opposite sides parallel. Those bases are parallel. Then it's a trapezoid, and that's it. Isosceles trapezoid has a lot more going on. Okay, the legs are congruent. So AD and BC are congruent. The bases are parallel. AB is parallel to DC. The lower base angles, D and C, are congruent, and the upper base angles, A and B, are congruent. The diagonals in an isosceles trapezoid are also congruent. Okay, and any upper base angle is supplementary to any lower base angle. For example, A and D, or A and C. Okay, those guys are supplementary. B and C are supplementary. B and D are supplementary. All right, that's what that last one means. So we're going to use some of these properties here in a couple problems. We're going to get construction with it, get construction-y with it, and we'll also get a little bit mathy with it. All right, so Will Ferrell and John C. Reilly need more room for activities in addition to the bunk beds they made. They are building out a bay window, which is pictured below. It's an isosceles trapezoid. Now they need to figure out a few more missing lengths and angles before they start using power tools, even though they're not supposed to use power tools. They all know power tools. What fancy math properties did you use to figure this out? So we're going to figure out some awesome lengths, and go from there. Cool. Let's do it. So we've got an isosceles trapezoid. Now what do we know about isosceles trapezoids? Well, if we pop back to that wonderful family tree, we know that any upper base angle and lower base angle will be supplementary to each other. Okay, so here's our properties over here for a nice little reference. You'll want to have that up a lot of times when you're working with these quadrilaterals at first, and then you'll start to remember them. Okay, so an upper base angle is supplementary to a lower base angle. So what does that say about angle X over here? Well, X is going to be supplementary to the 120 up here, so that's going to have to be, what, 60 degrees then? They add up to 180, so 60 degrees. Awesome. Cool. I'm going to use a different color, actually. How about blue? Alright, so I've got 60 degrees for X. Now I need to figure out Y. Okay. Well, let's see here. I've got a couple angles. I've got 9 feet up top. I've got 18 inches for the total out of this bay window, right? You can think of it as like your height of the trapezoid. I'm going to go ahead and convert the 18 inches into feet. So if there's 12 inches in a foot, I'm going to have 18 inches going to be 1.5 feet. Okay? Now you may be wondering, how the heck did I get 1.5 feet? So maybe we can go through that here real quick. Let's just say, okay, well, we got 12 inches in a foot, right? So if 12 inches is 1 foot, then 18 inches is how many feet, right? We'll call it Z so we don't get confused with any of the other variables, right? So we've got inches up here over my feet. And that's just a simple conversion type technique there. You can set up a some cross multiplication, set up a proportion to figure that out. So I've got 18 is equal to 12Z, and if I divide by 12, I'm going to get Z equals 1.5 feet. Okay, awesome. So that's what we've got for that one. We could probably use that. I'm just going to stow that work away over here nice and small. All right. So I've got 1.5 feet. I've got common units now for my lengths. That's great. How am I going to figure out the Y length? Well, I am always a big fan of setting up triangles and rectangles whenever I'm having a tough time with stuff. Okay, so let's work in red ink now for figuring out our Y. Okay, so if I were to do a better job this time, if I were to drop down vertical lines, I've essentially created a couple right triangles and a rectangle. Well, what do I know about a rectangle? I know the opposite sides of a rectangle are congruent, much like a parallelogram, right? It takes those same properties. So this right here has to be 9 feet. The opposite side has to be 9 feet, right? Because it's a rectangle. The opposite sides are congruent. Awesome. All right, well, we've got 18 inches, which we converted to 1.5 feet. So I know that this height is 1.5 feet. And I know that this angle over here is 60. So I can use some prior math concepts to figure out what this length is, which is going to be the same as that length right there, because it's an isosceles trapezoid, everything's symmetrical. Okay, well, how can I figure out, and why don't I label this guy, we'll call it Z over here. Well, actually, we've already used Z. How about we call it Q? That's fun. Okay, so how am I going to figure out that length? How about we get trig with it? Does that sound good? We use trig a lot. I think a lot of you are pretty comfortable with trig. Why don't we do that? You could also use special right triangles, 30, 60, 90. That'll do it. I'm going to go and get tricky with it, all right? So if I've got that triangle, I know 1.5 is my opposite side, and this is my adjacent side. What uses opposite and adjacent? Tangent. So the tangent of 60 degrees is equal to my opposite over my adjacent, which we called Q because we were running short on variables. So let's go and do some multiplication. I got to multiply by Q on each side and then divide by the tangent of 60. So what it really looks like is Q is going to equal 1.5 divided by the tangent of 60. Woo! This is getting cray already. But we can't forget that trig. Can't forget prior math concepts. Okay, so I'm going to pop out my TI-84 because I've always got it handy. It's always in my tool belt, right? Not really. All right, and I'm going to divide by so 1.5 divided by the tangent of 60. And I've got 0.866. And then a lot more. Okay, so it's under a foot. How would I figure out, so that's in feet, how would I figure out how many inches that is? I can multiply that by 12 and I'll get the inches, right? That's 10.4 inches roughly. If I multiply that by 12, I do get the inches, right? So anytime I know how many feet there are, that's all I got to do. Multiply by 12. But we'll keep it in feet. So I've got 0.866 feet for that part. I got 0.866 for the other part, so that's times 2, plus the 9 feet that we already have. And my y value is equal to, so I've got 0.866 plus 0.866 plus the 9 is equal to 10.73. 10.73, that's feet. Woo! That was a doozy of a problem. But let's recap what we actually used as far as our new concepts go. We knew that the upper and lower base angles were supplementary. That's how I got the 60 degrees, right? And then I was able to use that over here to set up some right triangle trigonometry. Right? I did do a little bit of converting so that way I could keep it all in feet like everything else. And I also used the properties of a rectangle here to figure out that this part would be 9 feet, so then I can just add these two congruent parts to this guy to get the whole thing. All right. Whew! That was awesome. That's some good math right there. So this next problem here, obviously not very construction-y. This is more of a traditional math type problem with a little bit of algebra review. You're already kicking it back into Algebra 2 next year, so we want to keep those algebra skills sharp throughout this semester so you're ready to rock and roll. But we can use our properties of these quadrilaterals, which we'll see frequently in the construction world. All right, so ABCD is a parallelogram. Solve for x and y. Well, what do we know about parallelograms? Well, in case you forgot, I just pop those properties up there. We know that opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and the diagonals bisect each other. Woo! All right. Well, what can we use here? Well, if we start with solving for x, I know my opposite sides those ones that are written in red there, those are the side lengths, A, D, and B, C. My opposite sides are congruent. Well, if they're congruent, that means that they are equal in measure. So x squared minus 4x is equal to 2x plus 16. Okay, well, how do I solve a problem like this? This is back to Algebra 1 review. This is one of the most important concepts you need to carry on to Algebra 2 next year. So I need to set this equal to 0 and solve by hopefully factoring or maybe quadratic formula. So x squared, if I subtract 2x, I get minus 6x. And then I would subtract, so I'm subtracting 2x and I'm subtracting the 16. So minus 16, and that's equal to 0. So I need to figure out what multiplies to negative 16 and adds to negative 6. It's going to look something like this. Oh my goodness, yes, this is bringing back nightmares from Algebra 1, I'm sure. So what multiplies to negative 16? Well, 1 and 16 do, 2 and 8 do, 4 and 4 do, but 2 and 8, if I did negative 8 and positive 2, that's going to multiply to the negative 16, and it's going to add to the negative 6, because I know I got to multiply to this number, and I got to add to this number right here. And that takes care of it. So now I can finish solving for x. Now the x equals 8, and x equals negative 2. Okay, so those are my two solutions, but wait, there's just a little bit more. I do need to check and make sure that this works in the original problem. What do I mean by that? Well, if I were to plug 8 in to this, right here, whole thing, I'd get 64, because 8 squared is 64, minus, well, 4 times 8 is 32, so 64 minus 32 is 32. That's a positive number. That sounds good for a length, right? If I plugged 8 in here, I'd get 2 times 8 is 16, plus 16 is 32. That makes sense. These are both the same thing. They're both positive lengths. All Gucci. Now, how about this one right here? So x equals negative 2. Well, if I plug that in, negative 2 squared is 4, minus 4 times negative 2. Well, a negative is going to make a positive. What's 4 times 2? That's 8. So I have 4. Plus 8 is 12. That's all good. If I plug it in over here, I get 2 times negative 2 is negative 4 plus 16 is 12. 12 and 12, we're all good. Both those answers work. Sometimes you get problems where only one answer works or none of them work. It's crazy. Maybe we'll come across one of those one time. Okay? Whew. All right. Let's solve for y. I'm going to toss this work off to the side, give us a little more room, change to blue. Let's do this. All right, well, what do I know about my consecutive angles? They are supplementary. That's the property we're using here. Let me circle that a little better. Okay. So what does it mean to be supplementary? It means they add up to 180. So let's do it. 3y minus 6 plus 8y minus 1 equals 180. Aight. So I've got 11y minus 7 is equal to 180. So 11y, I would need to add my 7 over, right? I got to add 7. So I'm done combining my like terms. Now I got to solve. So this one doesn't involve factoring, so I'm not going to set it equal to 0. I'm going to get my variable on one side, numbers on the other. So how do I get y alone? Well, I need to divide both sides by 11. So if I divide this by 11, I get y equals 17. Bippity bop. Now if I plug that back in, 3 times 17 minus 6. 3 times 17 minus 6 is 45. And if I do 8 times 17 minus 1, I get 135. That checks out. Those add to 180. It makes sense. They're both positive. We don't want negative angle measures. All good in the hood. Heck yeah, dogs. That was awesome. So again, we used our opposite sides congruent. And I also used the consecutive angles are supplementary. Okay? We'll get into the opposite sides being parallel and the opposite angles congruent a little bit more when we talk about parallel lines and their different angle relations in the next video. All right, awesome. America, freedom, rock and roll. Jenny's taking a nap right now. How you doing, Jenny? There's little Jenny girl. Just taking a nap. Okay.